Welcome back to another lesson. In today's lesson, we're going to learn about hyperbola. 3. We know the influence of A, influence of Q, and influence of P. So we're going to put all this together and we're going to have some examples and we see how we can answer the hyperbolic questions. And from here, we're going to speak about everything. We're going to speak about the shape, we're going to speak about the asymptote, the axis of symmetry, the domain, and the range. And that's everything you need to know about the hyperbola. So we're going to have an example. Example 1, we have y equal to 4 of x minus 2 plus 3. So from this equation, we can start with the shape. Right? So from this equation, you can tell already that the value of A is greater than 0 because the value of A is 4. That means you already know that your graph is defined on the first and third quadrant. So that is, you're going to find it here and here. So that's point number 1. What else do we know? So let's get to the value of Q. We have the value of Q. And the value of Q is equal to positive 3. Remember, the value of Q shifts the graph upwards or downwards. But because it's greater than 0, we can see that, oh, okay, it's shifting the graph up by 3 units. By 3 units. What else is the value of of Q is telling us? It is also telling us that we have a horizontal asymptote of y is equal to positive 3. Right? So we can already go to our graph and draw this one. So y is equal to 3. So we can draw that asymptote. So that is fine. We go to the value of P. Right? What is the value of P telling us? So the value of P shifts the graph to the left or to the right. But now you need to equate by how many units? So you have x minus P. I want you to get used to the fact that always do this so that you do not get confused as to where the graph is shifting. So you have x is equal to positive P. So, and in this case, it's 2. So it's 2 units. That means it's going to shift to the right by 2 units. So your graph is shifting to the right. And what else is this telling us? And it also tells us, oh, okay, we have a vertical asymptote of x is equal to positive 2. And we go there and draw that. So this is going to be our value of 2. And then we can draw that there. Right? So we know the y asymptote and we know the x asymptote. We also know that our graph is shifting. So what do we mean by that the graph is going to shift? So from the basic graph, I'm going to draw the basic graph and then you're going to see it shifting. So this is your basic graph, the pink line. And I'm going to remove it later. So without doing the points, I want us to shift this graph 2 units up and we also shift it 2 units to the right. So when we shift it up, it's going to be here. We're going to shift it 2 units and we also shift it to the right. So it's going to be something like that. And we also shift there. Right? So we shifted that. Now I'm going to remove it so that you do not get confused. So something that is left is the axis of symmetry. So what are our new axis of symmetry? So you can see that the graph shifted and therefore the graph is symmetrical by this line. You can see you're going to get that half and you're going to get that half. So it's symmetrical also by this line. Something that we noted from the past lessons that it's going to cut by your asymptotes. But now we have both asymptotes. We have P and Q. What is that point here? That point is 2 and 3. Which is the value of P and the value of Q. So we have a new point, therefore we can find the axis of symmetry. So from the basic equation, we know that we had y equal to x and y equal to minus x. So we're going to compute it the same way using this y is equal to mx plus c, because we want that equation. But the best way is to use the point to the slope to point form, which is y minus y1 equal to m of x minus x1. So that's how you compute it. And then we can see, oh, okay, we have y minus, what is the value of y1? The value of y1 is q. So you can have q1 here. You can have q. And the gradient is, we're going to start with the positive gradient, which is 1. And then we have x minus, this is the value of p. And then when you equate this, you can see that, oh, okay, I have x minus p, and then plus q. So the reason why I didn't put the values, I wanted you to note what is happening. You can see now from this, the transformation that happened here, it's you added your points. So if you do not want to go through this, because this will probably be 1 to 2 marks question. So if you don't want to go through this, you can just get to this point. Because this will work out, you're going to substitute your point. You have x, and the value of p here is 2 plus 3. And your equation is x minus plus 1. So that is your first equation. The second equation will be, so now what changed is your gradient. I want us to derive it so that when you get to just put your points, you know where it's coming from. So you would have here y minus q equal to m now is negative, and you have x minus p. So this will have y is equal to minus x plus p plus q, because q is going to go to the other side. So you see what changed here is this part and your gradient. So you can just go and write this part when you're answering your equation, knowing where it's coming from. So now our equation, the axis of symmetry, the second one will be minus x plus p is 2 plus q is 3. So we have y is equal to minus x plus 5. So these two equations are your axis of symmetry, because you know that we have two axes of symmetry when we're dealing with the hyperbola. And then what is left is your range and your domain. So let's start with the range. So you can see that your graph is defined everywhere on the y-axis, but except your asymptote. So here is going to be y is the element of real numbers, but y cannot be equal to q. The reason why I'm putting q is that you should always know that it's going to be the value of q. Even if q is 0, it's going to be y should not be equal to q. So in our case, it's y is not equal to 0. So that's what you need to know. And then we go to the domain. Similar to the range, we said x is the element of real numbers, and you can see that, but x cannot be equal to the value of p. And in this case, p is 2. So our answer is x should not be equal to 2, but it can be the element of real numbers. And we've covered everything. So you can, from the equation, which was 4 over x minus 2 plus 3, you can know what is your asymptote, what is your axis of symmetry, and you can find your range and the domain. It works the similar way. You can have a graph. So from the second equation, we're going to have, on the second example, we're going to have a graph, and we're going to have to find the values of p and q and a. So you need to be able to tell from the graph as well. Example number 2, you're given this graph, and then the question is, what is your vertical asymptote and what is your horizontal asymptote? And do not be confused. The vertical asymptote is the one that cuts the x-axis. Therefore, they want the equation of x. So you can tell, yeah, okay, x is equal to minus 1. And what is your horizontal asymptote? And the one that cuts the y-axis. So it's the equation of y, which is y equal to 3. Right? So do not confuse this. The second question will be, write down the axis of symmetry. And you know that to calculate the axis of symmetry like we did before, you wanna have to put it in the form of minus x plus c, or y equal to positive x plus c. And in this case, we're going to use the point to slope form. Or you can do what I said, that you can just get to the last part. But I want to derive it so that when you're doing it on your own, you know what to do. We're going to use this. We know that for this, it's minus x. So it's going to be negative 1. And our points, this is what you need to, what's important. It's these 2 points. So we can go to our equation and we know that these points are, this is where it's going to cut. Because now the graph is symmetrical by this point. It's always going to be your, I'm saying always, it's always going to be this point, which is your y asymptote and your x equation, your x asymptote. So we know that the point is minus 1 and 3. So we can put it down and say y is equal to minus x. So this is negative times a negative is a positive. So this is going to be positive x1, and in this case we have negative 1. And the y is going to go to the other side. We have y1, in this case is 3. So it's going to have positive 3. So we have minus x minus 1 plus 3, which is minus x plus 2. We go to the second equation. We have y minus y1 equal to x minus x1. And we know in this case it's positive. So we have y equal to x minus x1. And in this case we have minus 1. So it's going to be positive 1 plus 3. And we have x plus 4. So we have 2 equations. And you've answered that, and if it's 2 marks, you're going to get 2 marks, 1 mark for this and 1 mark for that. So we have vertical asymptote, the horizontal asymptote, the axis of symmetry. And then the other question will be, what is the value of a? Because, for example, you will be given your equation as a of x minus p plus q. I said f of x here. And they will ask, what is the value of a? Because you've already calculated the value of p and q. Or the equation, or the question will be, write down the equation of the hyperbola represented in this figure. So we're going to write down the equation. So to write the equation, we can start and say, okay, we have y equal to a of x minus p plus q. You can also say x of x plus p plus q, depending on what they gave you. If they don't give you anything, you can use any. It will equate to the same equation. So we're going to use this one, and we know that, okay, we do not know the value of a. So we say x minus, we know the value of p, because the asymptote is minus 1, right? So the value of p is minus 1. And we know we're going to put minus 1 here. And then we have the value of q as 3. And then we know that, okay, it's a x plus 1 plus 3. Now, how do we find the value of a? So you're going to go to your graph, and look for a point x, y, any point on the graph. And then you can equate the value of a. So we can take this value, we can take minus 3 is to 0, which is your x-intercept, and substitute it here. And then that will mean that y is 0. And then we have a here. We have x equal to minus 3 plus 1. And then we have plus 3 here. We take that to the other side. We have minus 3 is equal to a of minus 2. And then you multiply there. And then the value of a is 6. You are not done, because they did not ask the value of a. They wanted the equation of the hyperbola. Then you can substitute this back to there, and then you have the equation of the parabola, the hyperbola, is 6 over x plus 1 plus 3, and that is the answer. And you are done. So we have summarized almost everything. You can have the equation, and from the equation you can be able to draw the graph of the hyperbola. And sometimes, like in this example too, you can have the graph and you're going to have to write the equation. So you need to be able to answer both questions. And that is it for this lesson. Thank you for watching. Please do comment down below on what you would want to see on other videos. I would really appreciate that, and I will see you on the next video.